The goal of this week's investigation was to effectively determine a mathematical relationship between force and separation by measuring the force between two magnets as a function of the separation between their center of mass. Given a pair of magnets and a plastic tube, we were required to create an experiment to explore this. In order to measure the force between the separation of two magnets, the magnets must initially be repelled. To then observe the effect on the separation of the magnets due to force, we expected that some kind of mass had to be placed on one of the magnets while they were repelling each other and then continue to increase the mass, thereby increasing the force. Taking down the value of the length of the separation with the respective amount of mass, we assumed we could develop a mathematical relationship between force and separation. Initially, the experiment was set up so that the plastic tube was attached to a clamp with a scale placed at the bottom of the tube. The magnets were then placed inside the tube with the opposing ends facing each other so that they repel, thus being separated. Small metal balls of mass 8.4 grams measured by a scale would then continually be dropped inside the tube, acting as the force exerted on the separation of the magnets. We would then use the weight from the magnet at the bottom of the tube, which would theoretically change as more mass or force is placed on the separation. However, the scale could only measure objects with mass heavier than 300 grams. Thus, this setup proved ineffective. The final setup of the system had to be modified as shown here, with the end of the tube placed directly on the surface of the table while still vertically clamped to the retort stand. The magnets were then measured and marked at their center and were placed in the tube so that opposite poles were facing each other. The distance of their separation was then measured with a meter ruler from center to center at where the markers of each magnet were, and the separation between the two magnets was then continually measured with each metal ball placed inside the tube. We recorded at least 30 measurements for a wide spread of data for the results. To compute the masses into Excel, the initial mass point will be the mass of one magnet, which was 17 grams plus or minus 0.05 grams. The following mass points will be the mass of one magnet plus the number of balls placed inside the tube, which individually are already known to be 8.4 grams plus or minus 0.05 grams. The uncertainties in the mass derive from the uncertainty of the scale device. Using the masses, the force can be calculated using the formula F equals ma, where m is the mass calculated and a is the acceleration due to gravity, which is 9.8 meters per second squared. The separation length measured can be said to have an uncertainty of plus or minus 0.0005 meters, which is derived by calculating half of the smallest increment on the ruler. Using the data of the force and separation, a graph can be formed as shown here, where the relationship between force and separation can be described as with the increase in force, there is a decrease in separation. To form a mathematical relationship between force and separation, we can use prior knowledge that electric field is proportional to 1 over r squared, and describe the force in this case as some constant c over r, which is the separation length, to the power of a constant n. Using this, we can linearize our data by taking the log of both sides of the equation to derive an equation in the form of y equals mx plus b. Hence, by taking the log of the force and the log of the separation and plotting them, a graph as shown here is formed, where the linear relationship between force and separation is y equals negative 3.786x minus 2.1902. Subbing these values back into our mathematical relationship, f equals c over r to the power of n, c is 0.0065, n is negative 3.786, and r is some variable that is dependent on the separation length. Overall, from the experiment, it is seen that as force increases, separation decreases. Linearizing the data, we find that the equation representing the linear relationship in the form of y equals mx plus b is negative 3.786x minus 2.1902, and in the form of their relationship, f equals 0.0065 over r to the power of negative 3.786.